scale of measurement. This is the more scientific classification of data. The way a set of data is measured is called its level of measurement. The way a set of data is measured is called its level of measurement. Selection of correct statistical procedure depend on the level of measurement, or also we call as scale of measurement. Therefore, you should have thorough understanding about this scale of measurement. Not every statistical operation can be done with every type of data. Based on this level of measurement, scale of measurement, we can classify data into 4 types. First one we called as nominal scale data. Nominal scale data, or also called as classificatory scale data. Second type we called as ordinal scale data or rank scale data, also known as rank scale data. Then interval scale data and ratio scale data. First two types of data are qualitative measurement. Nominal scale and ordinal scale data. Qualitative measurement, meaning it will measure a quality of a variable. Nominal scale and ordinal scale measurement are qualitative. Those scale will measure quality of a variable. Then interval scale data and ratio scale data are quantitative data. So those data type will measure how many or how much. First, nominal scale data or classificatory scale data. These are qualitative measurement. Numbers are used as label. Numbers don't have the meaning of their value. That means magnitude of a number is meaningless. In this type of data, ranking is not possible. Example for this kind of variable is gender, seed color, body color, like variable. If we consider gender, we have two genders, male and female. Male and female. We can denote in data analysis male using 1 and female using 2, number 2, or vice versa. So male denote 1, female denote 2. So if we consider these two numbers 1 and 2, 2 is twice than 1 in magnitude, but it will not represent female is twice than male. So in this type of data, numbers we can use to identify the category. We cannot use these numbers to calculate some statistic. We cannot say average of gender is 1.5, since average of these two numbers are 1.5. Likewise, no ranking is possible. In this variable, we cannot rank which one is better, whether male is receiving rank 1 or female is receiving rank 1. We cannot rank these type of variable. So those numbers are used only as label. We use categorical data analysis technique. Categorical data analysis technique to analyze this type of data. For example, chi-square test, log linear model. There are many other categorical data analysis technique. You will learn those if you proceed with this subject in future. Then ordinal or rank scale data. These are also qualitative measurement. These variable can be categorized as in the ordinal nominal scale, categories can be ranked. Ranking is possible in this type of data. But interval between categories are not defined. Example, taste. If we consider variable taste, we can say this variable can have values not tasty, then little tasty, then tasty, somewhat tasty, or very tasty, very tasty. Likewise, we can have different categories. Here, we can rank these categories. You know, not tasty is in lower level. We can put rank 1 here. Little taste is will receive second rank. Tasty third rank. This is highest rank if we give highest magnitude to a superior category. But here you know there is a gap between this not tasty and little tasty. There is a gap. These two are different. There is a gap. We don't know how much of gap between these two. We don't know gap. We don't know the gap there. Also, there is a gap between little tasty and tasty. There is a gap. We cannot find by how much of gap between these two data values. Here also. In ordinal type of data, we can categorize data points, then we can rank data points, but interval between these categories, gap between these categories cannot measure or identify. We use non-parametric data analysis technique in order to analyze this type of data, like sign test, Wilcoxon rank sum test, Kruskal-Wallis test, and correlation. You are completely new to these words. We will learn those as I suggested. If you continue the statistics subject after this semester, if you want to know something about these words, you can Google and have some idea. Then interval scale data, third type of data. These data quantitative measurement. Earlier, two type, nominal or rank scale data are qualitative data. Interval scale data, quantitative data, quantitative measurement. Here in this type of data, this data point can be ranked. And interval between two data point is meaningful, not like in the ordinal scale data. Then, but in this type of data, we don't have true zero values. We don't have actual zero value. I will explain it. Then ratio between two units of measurement are not same there in this type of data. Example, temperature. If we consider several temperature values, 0, 10, 20 degrees, you know we can rank these values. This will receive lower rank, second highest rank, third highest rank. We can rank. And gap here, gap between these two data points, we can identify there is a 10 unit gap here. Here also 10 unit gap. We can identify gap between data points in interval scale data. That means interval scale mean interval is meaningful. In earlier ordinal scale mean order is meaningful. Nominal, in nominal scale, it is used only to name. There interval or order is not meaningful in nominal scale. Ordinal scale, order is meaningful. Interval scale, interval is meaningful. And another property I told that lack of true zero. Here we have measurement 0 degrees. At 0 degrees temperature, we will feel a temperature. If we consider weight, 0 kilogram weight mean we will not have any weight. But in temperature measurement, at 0 we will have temperature. It is a arbitrary value. Okay. So in this type of data, we don't have true zero value. And if we convert these data into another scale, we can measure temperature in centigrade and Fahrenheit. If we measure this data in Fahrenheit, this 10 will be 50 Fahrenheit. This will be 32 minus 32. This will be 68. If we consider ratio between these two scale of measurement, here these two data point have 1 to 2 ratio. 1 to 2 ratio. Then that is 20 is twice than 10. But same measurement we converted into Fahrenheit. Then here you can see same ratio is not there. So in this type of data, ratio between two units of measurements are not same in the interval scale data. We can use parametric data analysis technique like t-test, f-test, z-test or c-test. Z-test, you are familiar, Z-test, Z-test and ANOVA in order to analyze this type of interval scale data. So this data type from nominal scale to ratio scale, the properties are getting better. Here, these data have less property, somewhat higher property. Order is meaningful here. Ranking is possible. Here, order is meaningful, ranking is possible, and interval or gap is meaningful here, but don't have true zero. Here in ratio scale data, all those properties are there. Ranking is possible, interval is meaningful, true zero values are there, and ratio between two scale of measurements are same here. Unit of measurement are same. So ratio scale data, these are quantitative measurement. Data can be rank, interval between 2 point is meaningful, have true zero, ratio between two unit of measurement are same. Example, weight, length, height, area, all those things you are measuring. If we consider two data values, 1 kilograms and 2 kilograms. Here we can have 0 kilograms. That meaning there is no weight. 0. Not like in temperature. 0 temperature degrees in, there is a temperature. We feel coolness. But in weight, we don't feel any weight when it is 0. Then interval between two rank data can be ranked. We can give first rank here, second rank here. We can rank and have two zero value as I explained, and ratio between two unit of measurement are same. So if we consider these two data point, 1 kilogram and 2 kilogram, here ratio is 1 to 2 ratio. If we convert this scale to grams, there will be 1000 gram. here it will be 2000 grams. So same ratio here, 1 to 2 ratio is hold for this conversion also. So this is the highest type of data in the world, and you come across in data analysis. So most of statistical technique have developed to analyze this type of data. We can use parametric data analysis technique like t-test, f-test, z-test, click decision analysis, ANOVA to analyze this type of data.